Both of these two problems involve using a very useful tool called the solver. You probably have already installed it. If that's the case, you will find it under the Data tab and then here the solver. If not, you can find it from the File and then Options and then Add-ins. From here, I recommend adding the Analysis tool pack as well as the solver add-in. In my case, I already have it installed. So let's look at these two problems one by one. Problem 11. In problem 11, you are asked to determine the vertex of a quadratic function. If you don't remember what that is, here's a little reminder. For a quadratic function normally takes the form of ax squared plus bx plus c, as you're familiar with. But if you can rewrite it into this standard form, then this h and k are the coordinates for the vertex. The vertex is basically either the minimum value or the minimum point or the maximum point of a quadratic function. It depends on if your function opens up or opens down. So of course you can determine the vertex mathematically using the formula, but in our case we're just going to ask Excel to do that for us. So similarly, we're going to create a space to input our x value and a space to calculate the output value. In this case, you can have fx here or y here. They both mean the same. So we cannot do any calculation without putting in some value. Once again, Excel cannot be asked to solve for an unknown. So we have to always guess something. Let's just guess 0 here. And we're going to calculate the fx value using this equation. So that equals to -1 times x raised to the second power minus 2 times x again plus 5. Again, this x right here is simply a comment, a note. It's not involved in the calculation. It's this cell right here that's involved in the calculation. So that equals to 5. That's about right, 0, 0, 5, yes. Okay, now, how do we determine the minimum or the maximum value of this function? Let's assume we don't know if this function has a minimum or a maximum. So previously, in one of the previous examples, I showed how to use the what-if analysis and then goal seek to help solve for a specific goal, right? So in this case, we're going to use a solver, and as you can see, it has more options than goal seek. It can do the same thing as goal seek. Okay, in that case, similarly, we have this objective cell, and I want to set a goal for it. In this case, for example, we want to set that to 0 by changing this cell right here. And we can solve. And the solver has found a solution. Let's keep that. This is not the vertex, by the way. What did we just do? I accidentally solved for one of the zeros for this function, one of the solutions to when this equation equals to 0, just to demonstrate that functionality of the solver, which is similar to goal seek. But we need a minimum or a maximum. So let's go back to the solver. Let's say I'm looking for a minimum. And I don't want to make this assumption. I don't want to assume that the unconstrained variables are all non-negative, because we're dealing with mathematical problems that could have 0 or negative parameters. So let's unclick that and solve. Oops, we cannot find a solution. You see, Excel is trying very hard. It has tried many numbers. However, you cannot find a solution, which probably is a good indication that this function does not have a minimum value. Okay, that's okay. Let's try to find the maximum value instead. And now Excel has found a solution when x equals to -1, y equals to 6. That corresponds to actually a maximum value of our quadratic function. If you're interested, you can go ahead and try to use analytical method that you've learned from pre-calculus to confirm that -1, 6 is indeed the vertex point of this function. For problem 12, we have a function w that depends on two different variables, x and y. So x and y. I have now two inputs. And I want to determine the minimum value of w within a reasonable range when x and y are both between -10 and +10. So very similarly, let me get some xy value. 0, 0, always good to start. And let me calculate my w value according to this equation. So that equals to my x value plus 2 times y value minus 4 raised to the second power plus 2 times my x value plus my y value. Don't just type in y. That calculation won't work. But the cell that contains the value minus 2 raised to the second power. So when x equals to 0, y equals to 0, w, according to this equation, equals to 20. And now we need to find the minimum value for w. So again, let's go to data and then solver. In this case, we want to set this to be of our objective cell. We want this to be minimum by changing not just one cell anymore, but two cells, x and y. Now we have some constraints. The constraints are, so as our first constraint, this cell right here needs to be smaller or equal to, you can change this by the way, smaller or equal to 10. You can hit OK, but since we're not done with adding constraints, let's add another one. This cell again needs to be bigger or equal to -10. Add another one. The y value here also needs to be smaller or equal to 10. And by the way, this doesn't have to be a constant value. You can reference this with respect to a different cell address as well, if you wish to. For example, I can pick this cell right here. But in our case, let's do value 10. And our last constraint, this y value here needs to be bigger or equal to -10. And now we're done. Check our constraints. Everything looks fine. Now we're looking for a solution. So solver has found a solution and all constraints are satisfied. So this minimum value that the solver has found for w is not 0 but very close to 0. This is 1.44 times 10 to the -11th power, so practically 0. And this happens when x is also very close to 0 but y is close to 2. And if you don't believe this, when you are not looking, I created this table to try out some calculations. So basically, x varies from -5 to +5 along this column. And y value varies from -5 to +5 along this row. And these are the corresponding w value calculated from the x and y values. So as you can see, according to this table, which doesn't have all the samplings, obviously, according to this table, the minimum w value does occur when x is 0, when y is 2, and the w value is 0.